we discussed a question or an example in which we worked out the equations of the three things that we come across in kinematics, in fluid flow: streamlines, path line, streak line. And then we see, if we draw them, we draw the graph, we can see the flow field, and we can see how the streamlines, the path lines, and the streak lines look like for a given flow situation. We consider here another example, which is the velocity vector v is as given as u naught into sine of omega t minus y over v naught in the x direction plus v naught in the y direction. And obviously the subscript 0 shows that these are constants and these are not variables. And with this question we need to determine the streak line that path through origin at the given times, t equal to 0, t equal to pi over 2 omega. The path line of the particle that was at origin 0, 0 at t equal to 0 and the same point t equal to pi by 2, and streak line that passes through the origin 0, 0. Now remember, in our earlier examples that we worked out, we were not asked to write down the equations passing through a certain point. Only the initial condition was given. Here we have not only the initial conditions, but also the question requires that when we calculate the equations, we try to follow them and make sure that they passed through certain points at a certain time. These are as indicated. But the question is pretty simple, but it's only to demonstrate how to work out these equations, and that is why in this example this is very simple, and all these things are taken from the book that we are following, that I announced, for fluid mechanics by Yunus and Sanjela. So V is given as u naught sine omega times t minus y over v naught in the x direction, and in the y direction there is no variable, only a constant v naught. Whereas here there is a variation. You can see that there is time here, you can see that there is a y here. So the variables are there. Now these are the values that are written separately for the velocity components u and the velocity components v. I write these equations here again, and then when we try to find out the streamline, first we can use this. There are, of course, when we are trying to differentiate or integrate, there are few different methodologies that we can use and still end up with the same result. So here it is shown with one method. We have the simple one, the streamline equation, the ratio dx by u equals to dy by v equals dw by w is equal to ds. In a similar way, using that equation, and if we use that ratio and substitute the values of u and v naught, we obtain this equation. It's only a mere substitution of the values, and here for v we write v naught, so no variable occurring on this side. And again, by cross multiplying, we write it in this form, and this implies that we can write it in this form, and then we integrate it from 0 to x on the left hand side, and on the right hand side, since there is a y variable, we have to integrate it from 0 to y. After integrating it, we obtain v naught times x equals u into minus cosine of omega t minus y over v naught into v naught over omega with a negative sign within the limits 0 to y, as the integral has been showing. With these substitutions, we obtain these values. Of course, y is replaced by y, so the variable remains as y. But when t is equal to 0, then the functions that involve t that are affected, and cosine of 0 is 1, so that is reduced to 1. And all that we then have obtained here, sine or cosine of 0 is equal to 1. So then we obtain that x is equal to this value, where we have divided the upper equation throughout by v naught. If you can see this v naught is a common factor occurring in all directions, and this is a constant. So we are free to divide it throughout with this quantity, and the equation remains unaffected. We obtain this equation, and from this we note that when time t is equal to 0, we obtain cosine of omega t will be 0, and we will have only this value as non-zero. So that's what we obtain. And when time t is equal to the upper limit t over 2 omega, we obtain this equation that can be written as u naught over omega into sine of omega y over v naught. So we have two values for x. This is one value for x. This is for x, and this is for y.